Hello everyone, Monisha here. In this session we are going to discuss about exercise 8.3 which has only 4 problems. So in this we are going to prove whether the number is irrational or rational. So this is a easier session. Kindly concentrate so that you can understand that. Let us start the session. Let us move on to the first question of exercise 8.3, that is prove that root 5 is irrational. So before proving it, first we have to assume it is a rational number. Okay, so first you have to assume, let us assume that root 5 is a rational number. Root 5 is a rational number. Rational number in the sense it can be written in the form of p by q. So if it is a rational number, it can be written in the form of p by q, where p and q are co-primes. Where p and q are co-prime integers. You can simply write it as co-prime. So therefore, I will first cross multiply it, that is root 5 into q is equal to p. Next, we have to square it on both sides, that is squaring on both sides. So we will get root 5 whole square into q square is equal to p square. So here square and root get cancels. Remaining is 5q square is equal to p square. Next, I will take it down. So we will get q square is equal to p square by 5. So next, after this, let it be equation 1. Here we have to assume a fact that since 5 divides p square, 5 also divides p. So p is any number which is divisible by 5. So this is the assumption we have taken. So next, let p is equal to 5k. After this, let k be any integer. P is equal to 5k. Next, we have to do the same procedure, that is squaring on both sides. So p square is equal to 5k square. So p square is equal to 25k square. So here we know that p square is also equal to 5q square. So p square is also equal to 5q square. So instead of p square, we can write 5q square is equal to 25k square. 5 ones are 5 5s are. So q square is equal to 5k square. So again take it down. So we will get q square by 5 is equal to k square. As the previous, we can write since 5 divides q square, 5 divides q. 5 divides q. Hence, so this is the final answer. Hence, p and q have common factor. If they have common factor, it will not be a rational number. Common factor, that is 5. This is contradiction to our assumption, because since we have assumed it as a rational number doesn't have any factors, but here we have proved it as a factor. So this is contradiction to our assumption. Contradiction in the sense it is opposite to our assumption. Contradiction to our assumption that p and q are co-primes. P and q are co-primes. Therefore, our assumption is wrong. Assumption is wrong. Therefore, root 5 is an irrational number. So this is the way of doing the problem. The problem fetches 2 or 3 marks in your exam, and it is very important. I hope you understood this. Let us move on to the second question of this session. Just like the previous, we have to prove that 3 plus 2 root 5 is irrational. So first we have to assume it as a rational number. Let us assume 3 plus 2 root 5 is a rational number. So in rational number, we can write it in the form of p by q. So 3 plus 2 root 5 is equal to p by q, where q is not equal to 0 and p and q are co-primes. So it is slightly different from the way which we done the previous problem. So there we have done squaring on both sides, but if they give two separate numbers like this, then there is no need of doing any squaring on both sides. So previous problem only root 5 was there. Only at that type of problem we have to do the entire thing of squaring on both sides and all. So here p by q, I am shifting this 3, this set will become minus 3. So next, by taking LCM, it will become 2 root 5 is equal to p minus 3q whole divided by q. Next I am shifting this 2 this side. So it will become root 5 is equal to p minus 3q whole divided by 2q. So we know that from the previous question itself, root 5 is a irrational number. So since root 5 is irrational, since it is equal, then p minus 3q by 2q is also an irrational number. Which is contradictory to our assumption. Which is contradictory to our assumption. So therefore we have to write it as, therefore 3 plus 2 root 5 is an irrational number. I hope you understood this. Let us move on to the third question. In third main there are 3 sub questions. So let us do all the 3, and which is a quite easier one. The first question is 1 by root 2, which we have to prove it whether it is irrational. So prove that the following as irrational. So the same procedure we have to follow. First we have to assume it as a rational number. Let us assume 1 by root 2 is rational. So we know that rational is in the form of p by q, where q is not equal to 0 and p and q are co-primes. So 1 by root 2 is equal to p by q. We can take the cross multiply of it. So we will get q is equal to root 2 p. So q is equal to root 2 p, or we can take q by p is equal to root 2. So we know that these single digits like root 2, root 3, root 5, root 7, these are the numbers which are called as irrational numbers, which cannot be written in the form of p by q. So therefore, since root 2 is irrational, the number which we got, that is p by q. So if root 2 is irrational, then whatever we have assumed the p by q, so that is also irrational. Therefore 1 by root 2 is an irrational number. 1 by root 2 is an irrational number. So our assumption is wrong. So this was the assumption which we have taken, that is, let us assume 1 by root 2 is rational, which is wrong. 1 by root 2 is a irrational number. So this is the first problem. Second, similar to this, 7 root 5. In the same way we have to write, let us assume 7 root 5 is rational. So again, rational number will be in the form of p by q. So 7 root 5 is equal to p by q. Just we have to take this 7 down. So root 5 is equal to p by 7q. So again we have to write, since root 5 is a rational number, so since root 5 is also equal to this, so p by 7q is irrational number. P by 7q is also irrational. Therefore it contradicts our assumption. So therefore our assumption is wrong. So finally we can write 7 root 5 is an irrational number. 7 root 5 is an irrational number. So in the same way, there is one more problem, third one. It is all 3 problems are very easy. Third one is 6 plus root 2. Again we have to assume, let us assume 6 plus root 2 is a rational number. So before proving something as irrational, first we have to assume it in the form so that we can disprove it in the end. So we know that 6 plus root 2, if it is prime, sorry, if it is rational, then it can be written in the form of p by q. We can shift the 6 that side. So root 2 is equal to p by q minus 6. So root 2 is equal to p minus 6q by q. So since root 2 is an irrational number, root 2 is an irrational number which is equal to that is p minus 6q by q is also irrational. So which is quite contradictory to our assumption. So our assumption will be wrong. Our assumption is wrong. Therefore, 6 plus root 2 is irrational. So this was the last question of exercise 8.3. If you have any doubts pertaining to this section, please comment me on the comment section below. Thank you.